In this program, we'll change the color of the entire LED strip based on a temperature reading. Anytime we use the LED strip, we want to include the LED strip.h library. The library gives us access to special functions like setPixel, clear, and draw that are exclusive to the LED strip. To set up our LED strip, we need to give it a name, and I've named mine strip because that's easy for me to remember and easy to type, and we need to complete this LED strip function. The function has three arguments. First, how many pixels are on our LED strip? Second, which pin of the maker board is plugged into the green wire of the LED strip? And third, which pin of the maker board is plugged into the blue wire of the LED strip? Within the void setup function, use the pin mode function with arguments A1 and input to set up the temp sensor. This is going to be in the smaller block of ports near the bottom of MakerBoard. And make sure you review the parts list or the component card to get the sensor plugged in correctly. Within the void loop, we're going to create a variable for the temperature reading. When creating a variable, first you type what type of variable it is. This is an integer variable, shortened to int or int, and that means the value of the variable is always going to be a whole number with no decimal places. Next, give the variable a name. I'm using Temp because the variable value here is going to correspond to a temperature in Fahrenheit. After an equal sign, we give the variable its value. This variable value has two parts. First, the code will take a reading from port A1. The temperature sensor is going to send in a voltage that's not exactly a temperature. So we need to multiply it by 0.46 to convert that voltage into a temperature in degrees Fahrenheit. So now we have an integer variable called tempf, and the value of the variable should be approximately the temperature in Fahrenheit. Next, we have an if-else statement. This is where we're going to determine what color the LED strip pixels are. This if statement has two main parts. Between its parentheses is a condition that's checked every time the if statement runs. Between the curly braces is the code that runs when the condition of the if statement is true. So if the value of the tempf variable is greater than 80, this code will run, and this is just one function, the setPixel function. The setPixel function has three arguments here. First, which pixel or pixels do we want to light up? We're using strip.all as the argument so that we're lighting up every pixel on the strip. The second argument is a color value. This can range from 0 to 299. 100 is red, which I think corresponds well to a hot temperature, so I chose 100 to show if tempf is above 80. The third argument is the brightness on the LED strip. This is like a percentage. It ranges from 0 for not bright at all to 100 for maximum brightness. The reason that we're setting it to 10 is that the temperature sensor relies on steady voltage to give a good reading. If you're using the LED strip at maximum brightness, then the LED strip is using a lot of voltage, and it can throw off the reading from the temp sensor. So by using only 10% brightness, we can still clearly see the LED strip, but we're not interfering with the readings from the temp sensor. If the condition of the if statement is not true, the program will skip the code within the curly braces, and next it will find this else if statement. The else if statement also has a condition between parentheses, and if that condition is true, the code between its curly braces will run. Remember that the condition of the else if statement is only checked when the condition of the if statement above it is not true. So, if the temperature is not greater than 80, the code will check is it greater than 70. If it is, the setPixel function will set the entire strip to a color value of 200, which is green, and a brightness of 10. If the if statement condition is not true and the else if statement condition is not true, the else statement on line 20 is going to run, and the actions inside the else statement are another setPixel function, setting the entire strip to a color value of 1, which is blue, and a brightness of 10. Only one of these setPixel functions is going to run each time the void loop runs. So when the code reaches line 24, it's going to use the strip.draw function to send whichever setPixel data is true to the LED strip and display it. Then we have a delay of 500 milliseconds, or half a second, before the code reaches the closing curly brace of the void loop and jumps back up to line 12, where it refreshes the value of temp F by taking another analog read from port A1, and then starts to check the conditions of the if and else if statements again, deciding which color to set the LED strip.